Okay, let's move on. So why Composite? This is the first question which we want to clarify. We want to give you a bit of a background of why we've been doing it and what is really making Composite special. From the very beginning, when we are thinking about our tools, which we use for our design work, we as a company have quite a bit of experience in design. We wanted to have tools which allow us to be quite efficient and fun in providing the design. And we didn't find those tools at the beginning. So what we are looking for a solution which will allow us to take the design from the napkin or design sketch to the level that you can confidently design detailed design part. And this is something that we're missing, and we took a challenge to develop this tool to give tools for people to do it efficiently. Yes, so we know that you need to have the right tools. This is the fundamental thing when you want to solve problems. And very often we are in the situation that basically we are trying to solve problems, and before trying to solve problems, we're solving the lack of tools. And this is really what's stopping and making the process not efficient and frustrating. We want to change it. We want to provide efficient and fun tools for the designers and development teams to be able to design it. You don't want to reinvent a hammer when you want to hit the nail. All right. I want to give you basically 6 features that makes Composite really unique and efficient. And the first feature is the collaboration integration. Our platform is based on web-based architecture, which means that you can very effectively collaborate and integrate all your processes in one place, meaning that you can log into the one environment with team accessing all the data in one place. Okay? It enables all the teams to work efficiently at the same time with the same set of data. And this is something which was allowed by having a web-based architecture. Another feature which we think is quite unique and quite fundamental to our tools is that our tools have been developed specifically dedicated to composite design, meaning that all the workflows and algorithms that we implemented in our tools are dedicated to composite. Having said that, we have full flexibility to approach other materials and design problems, not only composite in the platform. Okay? As I mentioned, because of our software architecture based on web and cloud-based solutions, we can centralize our database management. So all the data is in one place, is consistent. This is really a quality control feature of our platform, which allows working with the same set of data. This includes data, material data, or reports, or revision and control systems, which are part of our platform. Another important feature, which is unique feature of our tools, is our agile design workflows. What it means that we can have a fully dynamic design experience, meaning that many people can work on different elements of the projects, changing it in different places. And we are going to present it on live demo how it works and what it really means. Agile design workflows is based fundamentally on IT project management, which meaning that you can change things quite fluently at any point in your design process. Next feature is a feature which is related to automatic project documentation. Throughout the project management and project development, one of the things which are quite inefficient in many cases is the documentation. We managed to build up the automatic documentation engines, which are basically integrated with other tools, allowing you to produce reports which can be shared online, but also send us a PDFs and so on. This is quite an efficient way of transferring the data from the design. And lastly, is quite unique flexible licensing model. Our licensing model is basically a mixture of subscription and usage-based model, meaning that we have quite low entry costs. You can adopt this solution very efficiently without having to buy quite expensive licensing. You can start with a flexible and low-key plan and adopt your usage based on your needs. This allows you to have as many users as you like. Our licensing is not based on number of licenses. You can adopt and scale your needs as you go. So you can imagine that you have projects that needs more resources, you can scale it up. This is a really unique and quite efficient way of adopting this solution. Okay. All right. This was quite broad view of why Composite, and now we are going to show you a few examples which give you the taste of what can be done in Composite. I will pass it to Ola, and Ola is going to explain the projects, and I'm going to help as well.
Okay, first example, kill structure. Basically, it's a beam design, of course, as you can see. The geometry was imported from a DXF file, so very quickly and efficiently we were able to design a beam section, apply it to the geometry you can see on the right top corner, and then quickly get a results for a load case presented on the right bottom corner with the results.
In a live demonstration, we are going to show you how to design beams. This is an example of more complex design, which is grillage design, allowing you to examine and design the more complicated structure. This is the example of the kill structure of the yacht. Right?
Yep. Okay, now a panel. We were analyzing the backing of a simple panel, but you can see it's reinforced only at the top middle part by some UD tapes. Here I chose only a few pictures of the panel. Please, if you can show the first and second backlink modes for the panel.
We support different analysis types. We support backlink. We support vibration with stress, pre-stress. So it's quite efficient way of solving certain problems.
Okay, a little bit more complex structure, a composite bridge. Very shortly we will release a tutorial on how to design exactly this structure. As you can see, we've analyzed beam deformation, but also model analysis of the beam was conducted, if you can please. Exactly. That's the first mode.
As you can see, this shows you the taste of what you can do in our platform. Obviously, you don't need to go as far as this. You can start with simplified design and as simple as laminate design, which we are going to show you shortly. But this gives you a good taste of what Composite can do only in your browser. There's nothing to install. It's only very simply plugin which needs to be installed, but in a matter of seconds you can have a full access to the quite comprehensive composite engineering tools. Okay, so those are a few examples that we would show. Now, before we jump into presentation, we want to clarify one thing which we believe is quite important for you to understand before you jump. It's Composite modules and workflows, which we are going to use across this live demonstration. Just to visualize it, we put together this simple slide for you, and we'll try to explain you the modules and workflows, and we'll refer to this graph along our live presentation. So as you can see at the top, we have a project space, which is basically a module which allows us to manage our projects. What it means, you can allocate roles and permissions, get the users, set up some settings for the projects, and set up different elements for the project which are necessary for you to design. Now, after this, you basically use different modules to carry out different parts of your design. First one is CMDB, which is our material database. Next one is the laminate space, which allows you to design classical laminate theory design or stacked laminates. The other one is the section space, which we are going to use in a second. Then it's the FE space, which allows you to analyze more complex structure based on FE engine behind it. And then there's a BOMGen, which is basically engine to generate bill of material and quantities for your design. And lastly, the last element is the report space, which allows you to create and manage your documentation in the design. Hopefully this was clear so far. We always look for the questions, so please don't hesitate to post the questions, and we are going to answer this shortly. By now, I would like to basically move it to the next part of our webinar, which is basically a live demonstration, which we are going to show you this workflow of downstream design and upstream modification, which is quite efficient. Okay. So we move on to the live demo. I'll pass you on to Ola.
Yeah. Okay, we were given a task. Our design brief is to design a composite cantilever beam to meet the design criteria. So the working load of 100 kilonewtons with a partial load safety factor of 2.7. The geometry is okay. The length of the beam 1 meter, okay. The maximum weight of my beam is 8 kilos, okay, and I have a cost of maximum 250 euros, okay. I think we have, okay. Okay, one more slide. As Radek told you, we will log into CompoSIDE, we will select a proper project space, and then I will move to CMDB to prepare my materials for the design. Okay.
As you can see, Ola is logging into basically using our browser. We use Chrome to log into to our environment. This is a standard browser without anything particular. We are logging into our account. And after Ola is logged in, she'll be able to select the project for which we are going to build our design. So at the top we have Project Navigator. They have different projects in here, but we've created before our webinar one project which we are going to use to start design.
As I said, I will go straight into CMDB, Composite Material Database. Every customer who registers for CompoSIDE license, even a trial one, gets access to a material database pre-selected for you. So I'm just going to choose one UD ply and one biaxial that I'm going to use in my design, and move it to project materials. I will also need one core material.
Moving, meaning copying to project materials, which allows you to manage your project's materials, adapting it for your needs if needed, or creating the set of materials which are used across the project.
Exactly. One more thing I need to do, I will create a material selection.
Material selection is used to manage materials, to allow you to filter groups of materials for better handling in a project, as you are going to see in a minute.
Okay, I'm all done. All my materials are selected, and I can use them in the project. I'm just going to show you the properties of my plies, just for a quick review. Normalization of my plies.
This is only
okay. This is just for a preview of the functionalities available in CMDB. Oh, sorry. Okay.
So we've completed the CMD step, which allowed us to create and prepare materials. There are more advanced functionalities in CMDB, but we want to really show you the workflow. Remaining parts of it, you can watch our tutorials to learn more what you can do in our CMDB module.
Okay, so now I'm going to jump into Lamina space to design a simple laminate, which I will use. Okay, Lamina space is here. Create new laminate. Okay. As you see, it's really simple and easy to use. 45. And I will also need a car.
We're creating simple sandwich laminate, which we are going to use for our beam design. We are creating the laminate for the shear webs, which are going to be used in a minute.
Okay, my very basic laminate properties are here. I can see the unit price, the density. If you would like to check the engineering constants, as we call it, the stiffness properties, they're available here in the top tab.
Mm-hmm. You can examine your laminate in more details, you can apply loads and so on, but at the moment we want to really move on and start designing the beam section for now. But as I told you earlier, you can do your design even at this level. You can start with a laminate design at the laminate level.
Okay, that's done. We have our simple laminate, so now I will move into section space to design a section of my beam. Okay, section space is here. Okay. Create new beam section. I would need a thin wall section. Okay. If you need a little bit more complex geometry, you would probably import it from a DXF file. But our geometry that we're going to use today is very simple, so I'm going to just create it from scratch.
We decided to create a box beam with basically 2 shear webs and 2 cappings, top and bottom. Ola is basically creating very simple geometry using our geometrical engine in section space. As you can see, it's quite efficient. We also have very useful constraint tools, which allows you to design it very quickly and then modify it if needed using simple parameters. So as you can see, Ola is creating very quickly the beam section. I can see that Ola is trying to push the design of the beam to 200 instead of 250, which was the assumption.
Yeah.
But we'll see what happens.
Okay, I'm going to just group my elements so it's easier for me to edit them later on. Sorry, caps lock on.
Grouping of elements just allows you to modify them quicker later and just organize your section. You can create arbitrary sections. It doesn't need to be like that. We can create quite complex section, open and closed section with full set of properties derived from the geometry that we use.
Okay, now I'm going to assign my materials. So in the cappings, I'm going to use just my UD plies that I've selected earlier. Okay. And in the shear webs, I'm going to use the laminate that I've created just a few minutes ago. Okay. My section is ready.
So now we can see, we can really quickly estimate the mechanical properties and also some properties like weight and cost per unit length of the beam. This shows you how quickly you can get the properties which allowing you to first estimation of your design.
We will get a little bit further. We will see what is the allowable load for my section. I wanna.
We are checking shear load at the moment. So how much the section can take?
Not that much.
Okay, we have around 100 kilonewtons, and we know there's 270 kilonewtons from the design brief.
See how we are on the looking better on the moment.
Okay, we have 278, which is exactly where it should be. Allowable loads, meaning is we can check quickly capacity of those of this section, defining the load, which gives you reserve factor of 1. So Ola is going to show you how you can check reserve factor in the beam section now, but for this allowable load.
So getting back sorry, to our presentation, we've just designed the section, and I'm going to show you the reserve factor once I'm done with the 3D model, okay? So this section is ready to be saved, and now we are moving into epi space. I'm going to create an epi model. Okay. Okay. I'm going to start with the geometry of my beam. So it's going to be 1 meter long, as my brief said. Okay. I will probably need a point to get the right orientation of the beam.
As you can see, again, for EpiSpace, we have certain functionalities embedded in the editor. You can create very quickly basic geometry, either through manual input or by importing certain formats of geometry, for instance, DXF. But this allows you to very quickly define the geometry. At the moment, Ola is importing section from section space, defining the beam with these properties. And she's going to show you the orientation or the visualization of this beam. As you can see very quickly, we have this section visualized and ready to go further.
Yeah, I'm going to apply boundary conditions, so it will be fully fixed at this end. And then I'm going to apply the load. The working load was 100 kilonewtons, but we want the output of the ultimate load.
As you can see, we support integrated safety factors in the system, so you can work on the different load levels and apply certain safety factors. Ola is a little bit quick, but what we are going to do as well, we're going to show you that we run vibration analysis, which was part of the brief to meet the stiffness criteria. At the moment, as you can see, we send our calculation into the server. It's calculating at the moment the problem. Now the results have been sent back, and Ola is going to present the results. You can see the deformation. Those are, of course, ultimate deformation, which is quite long, but at this moment we are going to look at beam element results.
Okay, one more thing. We said at the beginning we will view for usage. So here you have this green CompoSIDE unit icon. We can check this. Calculating the reserve factors for this beam will cost you 2 CompoSIDE units.
It's very transparent. Before you click any element which is basically charged with our composite units, you can check how much it costs and decide whether you want to do it or not. Cost of calculation is based on complexity. We charge to basically maintain our infrastructure, to make sure that all users have access to our resources, and also that you have full transparency of how much it costs you to run.
Okay.
One more thing maybe on the cost, to be clear. There are many things which are included in the subscription. As you probably noticed, there is nothing to have been charged when we are designing laminate and so on. So subscription covers quite a lot of things, and also with the subscription you have a pool of composite units that you can use over the month. Okay,
I was a little bit too optimistic. My reserve factor is only 0.5, so I will definitely need to work on my section. I can review more detailed results back here.
And And this is where it really starts to show you how quickly you can go back and change certain things. We are back in a section space.
Yeah.
And
I'm very bad on the she webs, so I decide I'm going to go back to Lamina space to add one more biaxial ply to my skins. Okay? No worries. Okay. That's done.
so Ola has just simply went back. It was even too quick for me, I have to say, but Ola went back to Lamina and basically doubled the number of shear plies in the basic laminate that we
In both
have.
skins. Yeah. That's already updated here. The data, the fresh data was imported to section space. I think I'm going to need to follow the design brief and make it also a little bit higher.
Okay.
Okay. Let's not forget, I also have a specific cost and weight. Okay. I think I'm okay now. Let's see how the section does now. The load.
So we've changed the specification of the section, and Ola is checking now what is the reserve factor for that.
Okay. I'm gonna need to get a new load. Yeah, rerun the calculation. Okay. Okay. Yeah.
Okay, we're going back to our beam reserve factors, and Ola is recalculating our reserve factors, and after our change in the section geometry and also laminate definition, our reserve factor, which is above 1, we can examine what happens and determine what is wrong and which element is basically failing, and still optimizing the same way if you want. At the moment, Ola did a really good job. She optimized it quite efficiently. Now the design is basically ready to run. Now let's try to check whether we are meeting another brief, which was the stiffness brief, which was the frequency requirement. We had 100 Hertz. You can see that the first mode is 115 Hertz for this particular beam, and Ola is going to show us the visualization. This basically is this visualization. So we can see that it's a sideways vibration of the beam, and it meets our criteria.
Yeah.
Okay.
Okay. Let's go back to the presentation. So my EPI model was done, and it's meeting the design criteria. Now I'm going to quickly create a bill of material for my beam.
So once your design is ready, you might want to share this information with the other stakeholders in your project, or maybe with other people that are involved in terms of manufacturing it or providing material quotations for you. So our application is really efficient to produce this document. At the moment, as you can see, with one click, Ola has created a bill of material. She went into the bill of material generation module and generated it for this particular product.
Yes.
Okay.
I have all the details I need. I have a cost of the raw materials that I'm going to use and the total areas and weights that the materials will cover.
Bill of material covers also the usage and wastage factors, so this can be incorporated in the costing.
Okay. What if you want to share the bill of materials with your external customer, manufacturer, or with anybody else?
This is quite simple. We can use another module in our application, which is the report space, which Ola is going to show in a minute. So you can produce a report out of the bill of material document which has been produced.
It doesn't let me go back to... Okay. Okay. So I'm going to simply right-click on my product, choose Create Function Report. Now I'm going to choose a template with costs. Okay, save.
This action produces the report, which can be then organized in our report space module. At the moment, it's been generating.
Okay. Okay. Sorry.
And this shows you the report in our application. Of course, you can share the link, which is at the top, and it's shown like that. You can send this link to other people. You can customize your report, and this is something that we could show you now, just adding a picture to the report or customizing by changing the logo of your report. At the moment, Ola is just adding a picture to the report.
Okay.
So she uploaded it before, and now this picture of the beam, which we've just designed, has been added to the report. Okay.
Okay.
This can be exported to PDF or sent as a link to the customer. What we do also, we provide the ability to control revision and issues of the documents, which allows you to maintain quality control. So we can issue documents at any point with full traceability of the changes and so on.
Exactly.
Okay.
Okay.
Now, after this kind of a loop, you can do another loop, and you can update anything on the way with the same kind of with the same process. You can go back to the material database and change the materials, replace materials everywhere. You can go to laminate and change laminate or different definition of a section and so on. This showed you how efficient you can be in that simple design, but still quite integrated design process that we showed you. As a summary, we've covered all the modules in this presentation, and we also covered the design brief. Our reserve factors are all above 1. And so we succeed to design this simple beam with you, right?
Yeah.
This concludes our live demonstration of that and leaves us to the last part of our webinar today. We hope that you enjoyed it. We want to go through the questions and answers now.
We have a few questions.
We have a few questions which we are going to pick up now. Let's try to answer them one by one. First question is from Nikhil. It's, can we import geometry and modify it to suit our needs instead of either making from scratch or just importing? At the moment we support quite a few ways of importing geometry, mainly through the standard format of DXF. We provide also quite a few efficient tools to create the geometry in our environment. We are working at the moment to add functionality to import step files to our application and also integration with third-party CAD tools. This is on the way. It's going to be available soon. At the moment, tool is really dedicated to do very quick and efficient design and not to do very, very detailed design of the geometry. Another question is quite interesting, is from Chris. Is, can you review RFs for shear and bending independently? Yes, you can. You can do it either from going into the section space and applying certain loads, so you can pick and choose which component of your load you are going to look at, and it will give you the reserve factor for the separate loads without combining them. Okay. Another question is, can we simulate dynamic loads like sine cubic nonlinear, for example, to simulate flutter or glider wing or wind turbine blade? At the moment, we don't support any dynamic analysis. It's just beyond initial design stage. We have certain modules which cover more advanced analysis or dedicated analysis for business-specific needs, like for instance wind turbine blades or yacht scan design. Those things are covered, but we don't have advanced FE functionality in there apart from what we've mentioned. So it's buckling and linear vibration.
Okay, there is a question if we could show you a shell example, and of course we were just discussing before the webinar that the next webinar will cover shell design process in CompoSIDE. So you're welcome to join us.
Exactly. We wanted to invite you for the next webinar. In the meantime, though, you can go onto our YouTube channel, which is basically available to all of you, and we have quite a few tutorials there covering the shell design. We are quite proud of this tool. It's quite efficient and unique in a way to design shells, and you can learn how you can do it from there. But obviously I'm repeating our invitations. You are more than welcome, and we look forward to seeing you in the next webinar, which is going to cover the shell design. I think remaining part of the questions we are going to cover and answer as part of our follow-up on this, unless there's any other questions, which basically... Okay, there's quite one question. There's one question: how many people can use CompoSIDE? This is quite interesting question. As I mentioned, you can add as many users as you like, even in the trial subscription. There's a limit to how many active users can be at the same time using your account based on your plan that you choose. So you can add as many users as you like, having some limits in terms of how many users are active. There's another question which is asking what FE solver we used in the background. We use our own or combination of open source and our own formulation of FE solvers, which we developed to make it efficient, and basically this is something that is quite unique in our view. We developed quite a few routines to make it really efficient for composites. So it's. But
then, of course, we benchmark it with other commercially available FE software.
As a part of this benchmark, we are going to give the document, and it is going to be available on our website soon with a full benchmark of our FE engine.
There is another question: is it possible to share material database between several projects? As I've showed you, I've copied the materials from our company database, so that's how you will share materials between projects. You can also duplicate a project, but that's kind of another story behind it. So yes, the database of your materials belongs to your company, and you can use the company materials in all your projects in CompoSIDE.
Just to clarify it, for commercial plans, we also give the access to material library, which basically is kind of a storage where you can copy your material either to company or projects. And then what you've seen is that we have that we can use project materials in one project. Then you have company materials which can be copied to the other projects and shared through this. As I mentioned, there are different roles in our application available, and one role is we call it material master, which is basically people. You could dedicate certain people in your company to manage your material data and copy from certain projects to your company material database, which can be shared to the other projects. It's quite flexible and secure.
Okay, there is another interesting question from John. are there any modules that are linked with any design standards?
Oh yes, that's a really good question. As I mentioned, we have some dedicated tools for business-specific or market-specific design needs. For instance, we have a module which is called YachtsCant. This is add-on which can be added to your standard set of modules. This module is used to design to carry design of the yachts, motor or sailing yachts, and it's basically supporting our GL or ISO standards for the yacht design.
Okay.
Yes, there's another question which is basically, there's a questions related to can we export material data to other third-party FE softwares. At the moment, yes, we have two ways of doing it. We basically can export it as a part of our export functionality either to ANSYS or to ISACOMP, or we can export it using our add-ons, which is basically full link with ANSYS. We can export not only material data but also laminate data and material data combined to ANSYS ACP solver. There's another question, how many materials, fibers, resins, etc. are included in your database. For the trial accounts, which are available to you for 30 days trials free of charge, we give around 30 materials or so as a part of the trial. This is full set of data which allows you to carry any design evaluation. You can create your own materials based on those building blocks which we provide as well, like fibers and resins. And for the commercial plans, we are going to give database which is more than 250 materials at the moment, including cores, resin, fibers, plies, and so on. And there's also one interesting, or two really interesting elements which allows you to create materials in the database. One is the micromechanical module, which allows you to create any material based on building blocks. And also we support layered materials, which allows you to create basically stack laminates, which are more than one layer.
Okay.
There's one question which we want to answer, is the question, how do I install the software? As we mentioned at the beginning, and this is web-based software, which doesn't require any installation apart from one plugin which can be downloaded from the internet. It's a secured plugin. And you don't need to install anything. You basically go onto our website, which is basically www.composide.com. And you can register for any of these plans that we show. You can register for a free 30 days trial, which provides you with the set of initial material data, initial set of 500 composite units, and access to all our modules, which allows you to play with it and see what you can do with it, and gives you also the feel how much it will cost you to run what you need, really. I think we've covered most of the questions. If we miss any of them, we'll basically let you know after the follow-up. Oh, there's one more. How do I know my data is secure? That's a really, really important question, so I'm glad that someone asked it, was Jonathan. And I can reassure you that our platform is run onto the most secure cloud solution in the world at the moment, with full compliance with security standards which are enforced by software as a service solutions. It's at the moment hosted, and there's only limited access to any of the data that is hosted there. We have external company which basically holds it for us. There's only 2 places in the world that can access this data. Your data is secure. You have a completely separate database. We do very regular daily backups, so it's quite secure system for you. And furthermore, it doesn't bring you any headache with IT. It's all covered in it.
You just open your browser and start using it.
Yep. All right, I think we are a little bit quicker than we thought. I'm not sure whether you want to know anything more, but I hope that you enjoy our webinar today. We would like to thank you for your time and for attention, and that you join us today. As we mentioned, we are going to plan to have another webinar shortly, probably in a couple of weeks, where we cover a little bit more advanced design using the shell elements. In the meantime, stay tuned with CompoSIDE, and of course we're inviting you for signing up for the free trial on our website and give it a go. Don't hesitate to get in touch with us. As you can see, we have quite a few channels that you can get in touch with us to get help. We have a quite comprehensive YouTube tutorial channel which is available for you with quite a lot of tutorials there. We have technical documentation which is part of our application, which will give you good guidance into certain functions. We have support chat which can be accessed at any point when you are working with CompoSIDE, which is in the lower bar, and also we have access to our support portal and the knowledge database.
One more thing from me. I know I was very quick today, but the purpose was to show you how efficient CompoSIDE is once you know how to use it. To learn how to do all the things that I've done today, just simply visit our YouTube channel and watch the tutorials that you think you need to watch.
Thank you very much for your attention, and lastly, the recording of this webinar will be available to you, and we'll send you the follow-up email. Thank you very much for your time, and hope to see you soon and see you using CompoSIDE efficiently. We hope you enjoyed it. Thanks a lot. Bye-bye.
Bye-bye.